Okay, so yes, the first page that I've given you is a formula sheet, and that formula sheet is really just to kind of keep the formulas organized in one place. That way, if we have a quiz or something, and I'm going to let you use that your formulas for it, you can just grab that out instead of grabbing all your notes out. So we're going to kind of keep up with that formula sheet as we go. We got 4 to put on there today, and then we'll have a couple more to put on there tomorrow. So please keep that handy. Now, as far as the other page, the one that says exponential growth and decay applications, that is your note sheet and the homework sheet I'll give you. So you're going to get a third page. But again, pretty simple assignment really today. Kind of changed my mind about that last part. So we're not going to deal with this concept of monthly today, all right? I just don't love it, and if we don't need it, I'm not going to cover it. So I'm gonna find out today whether we need it. If we do, I might throw it in. I don't know. I might put a video out on Friday, and it would be for the people who want to see it to get maybe like some extra credit on that assignment. We'll see. Okay. Now, here's what we are talking about today. There are a couple scenarios where they're going to ask you to solve when some value is either doubling or tripling. So obviously, when we talk about doubling and tripling, that without a doubt is exponential growth, right? It's getting way bigger. Sometimes this is used in things like bacteria. Sometimes it's used just kind of for fun, which I'm going to show you here in just a minute. But again, the formulas for these are pretty basic. You're going to have in both of these some principal amount that's getting invested, or that is an initial amount. And then if it's being doubled, the base of your exponent will be just a 2. Okay, it's like 100% growth is what causes that to happen. And then if something's being tripled, the base of that exponent will be a 3. Now this formula is used in like different scenarios. So for example, it might be about bacteria growing every hour. So how much grows per hour? So X or T is X, or hours. It might be about days. So T might be in days. So that could change. Now, some of the formulas we're going to deal with later, they don't. T represents specifically time in years. Okay? So that's the first equation, and this is where you see it, and you'll be able to read it and decipher it in the word problem. And I know that that usually causes some issues, word problems, but remember, what's the key to being successful at word problems? What's the key?
Keywords.
Keywords, okay? You gotta focus on keywords, key numbers, even in mathematical word problems. You got to focus on the numbers and make sure you're putting those in the right places. So word problems don't have to be terrible. Just got to focus on concepts. Like, for example, look at this first question. A bacteria culture contains 200 bacteria. Obviously, that's going to be important. It says the number of bacteria doubles every what? Hour. So if I was looking at those two equations above, without a doubt, I'm dealing with which one? Because of the wording here. Which one am I dealing with? What's the key word that tells me which of those two I'm dealing with? It says the word doubles, right? If something is doubling, what's the base of that exponent need to be? It needs to be a 2. So we're going to use that first formula, okay? Now, here's what the question actually asked us. Write a function, y. So instead of a, they want us to name it y, no big deal. Sometimes it does that. Sometimes they'll ask us to put it in function notation. They may say use f of x or something like that. Then it says to represent the number of bacteria in the culture after x hours. So where's x going? If it represents hours, that's your t, that's your time. Alright, so let's see the rest of it. What's my P value? What does P generally represent?
The control.
Not really in this case. I guess it's
Like the base value.
the original value,
Yeah.
right? The initial amount. In this case, that initial amount is 200. The 2 is just a part of the formula. And then, of course, we said already to put X into T's position because it represents hours, time and hours. So my equation is simply Y equals 200 times 2 to the X. And that's it. Okay? Very simple formula. Very easy to solve because part B just simply says how many bacteria will be in the culture after 6 hours. So we're literally going to do what?
Replace X with 6.
We're going to replace X with 6. So I'm going to go to my calculator and I'm going to go 200 times 2 raised to the 6th. So everybody type it in. 200 times 2 raised to the 6th. And tell me what you get.
12,800.
So after 6 hours, you're going to have 12,800 bacteria in this culture. Okay? That's fast, isn't it? And that's the thing with exponential growth. You know, the bigger it's growing, the faster it's growing, it gets kind of out of control, all right? And how fast it can actually increase, which we're going to actually see in the next example. So let's read it, example 2. Each day, an investor deposits 3 times as much into the bank as she did the day before. Her initial investment was $2. All right, so what's my keys, guys? What's the really important concepts that you need to see in this equation? What's the first thing you see that's important? In that word problem I just read. 3 times as much. That's telling me what? I'm using what formula? Tripling. 3 times, okay? You got to understand the connection in those words. 3 times means you're tripling something. Okay, what else is important in here? Huh? $2. That's my initial investment, right? And then another one that's important is each day. Okay, just to know that this is time in days. Okay, time in days. So here's my equation. It says write a function to represent our daily deposit. That's Y. We know that that replaces A. That's my accumulated value. We'll talk about it in a second. Then we've got P. That's my initial amount. What was that initial investment? $2. It's tripling, so we use a base of 3. And then, of course, on day X, so we replace T with X. So my equation is Y equals 2 times 3 to the X power. 2 times 3 to the X power. And it says, what will her deposit be on day 8? What will her deposit be on day 8? So how do I figure that out? Somebody say plug in 8 for X. Somebody say that. Very good. We're going to plug in 8 for X. And I'm going to go to my calculator. 2 times 3 to the 8th power. So how much is she going to have to deposit into the bank on day 8? Huh? 13,122. Yeah.
You sounded way too excited about that.
It's crazy, right? So here's a question for you. Would you rather someone give you $1 million today, or would you rather them put a penny in your bank and double it every day for a month?
$1 million.
Really?
Yeah.
How much would that go up to?
Well, let's
A penny
see.
a day.
Go to your calculator.
30 days. 30 pennies. 30 cents.
You
Plus,
double it
you
every
double
day.
it? Oh, well, then 2 pennies, 2 pennies, 1 penny. No, it's still not going to equal $1 million.
Okay. So watch this. 0.01 is the initial investment, right?
Yeah.
You're doubling it every day for 30 days.
Enter. Whoa, what?
Wait.
I just did that.
Wait.
That
So,
doesn't even.
That's
on
you
the-
get- you get
On
one
the
more.
30th day, you're
Yeah.
getting $10 million.
Dang.
So on the 29th day, how much would you have gotten? 5 million. How much would you have gotten on day 27 or 28? Half that, 2.5 million. So you're talking about a lot more money than $1 million.
Wow.
So
But
would
you
you?
can invest $3 million to get triple that.
I
Don't
guarantee
invest
you,
your
if
whole
you
million.
invest $1 million for 1 month, you don't make as much as you would if you got a penny the first day and doubled it every day for a month. No way, no how. That's a
I'm about to
trend.
start doing that. I'll be rich by the end of the month.
In a month, you could have 31 days.
I mean, if you accumulate that, it's insane.
That doesn't even seem.
So you can
Is
go
that
to the
number
bank
not-
and just put 1 penny the next day.
So one
Yeah, isn't
penny
that-
one day,
yeah,
2 penny the next day.
Is that what you're trying to
4
say?
penny the next day, 8 penny the next day, 16 the next day, 32 the next day, 64 the next day. It does kind of add up quickly.
When you get out of the city.
Okay, for a month, if you accumulated it, if you accumulate what you would get, if you did a penny at the beginning and you doubled it every day, and you accumulate that deposit every month, it's $21,474,836.46. So, 21 million in a month. So yes, you'd rather have a penny a day. Now listen, at day 20, you're still kind of wondering what's gonna happen. At day 20, it's $10,000. At day 15, it's barely anything. I think it's like, at day 15, it's still just 327 bucks. So from day 15 to day 30, it goes from 327 bucks.
Yeah, but
up
at
to
some point,
10
that
million.
can actually work out, 'cause at some point, you're depositing way more money than you even have.
Well, yeah,
Yeah, so
I'm
like,
saying if someone.
oh, somebody just
Yeah.
randomly was like, hey, I can do this for you.
Yeah,
Is that not in pennies though, or is that in
Yeah,
total?
remember.
no, it changes, cause I use .01. So it definitely is in real dollar bills, okay? So if you ever ask you that, you know transfer is,
Yeah,
okay? You want them to start with you a penny and double it.
Yeah.
Alright, anyways, no one will ever ask you that, guys, so I'm sorry. to
what if they
disappoint you.
do,
Well, then you are a lucky creature.
I want my penny a day.
right?
You want your penny a day
Double,
double.
double.
Yeah, for sure. Alright, so, here's the deal. You guys remember when we talked about exponential growth and exponential decay? And we did the graphs for them? Do y'all remember what caused it to be a growth versus a decay in our equations? We talked about it extensively.
If one was like, more than, help me out.
You're right there. You're on the
More than
cusp.
More than
one?
0.5.
More than one. Remember, if that value, if the base of your exponent was greater than 1, it had to show exponential growth. If the value was less than 1, like a decimal, or like a fraction, 2 halves, or 2/5, or something like that, then it was less than 1, it would show exponential decay. Same is true today. So there are 2 types. There are types of investments that will grow, and that is called appreciation. And then there's types that decay, and those are called depreciation. All right? And here's how you distinguish them. Look at the 2 equations. In both of the equations, the base of my exponent is either 1 plus r or 1 minus r. So that should make sense because greater than 1, it grows. Less than 1, it decays. So appreciation grows. And how is that? Because it'll end up being 1 plus r, which puts it above 1. Where depreciation decays, so 1 minus r puts it below 1. So that should make sense. Now here's the deal with this, and I'm not even kidding you. These problems are 100% simple, except for one thing. People always forget how to deal with these things. The rates, okay? That's the number one thing that causes people to miss these problems. They don't convert their percentage rates to decimals correctly. So when they enter those, it gets it all messed up. All right, so let's go to our formula sheet real quick. Everybody, go to your formula sheet. Let's go ahead and fill out what you should already have before we move forward. You should have these all named, okay? A, we like to call accumulation. Some people say it's your total amount, but I like accumulation. It's how much is accumulated. It's your after amount, okay? It's how much you have after a certain time, at a certain rate. Your P is your principal amount, not principal, principal, okay? PLE, and it's what we call the initial amount, the initial investment. Then T, of course, is going to represent your time, and most of the time it's going to be time in years. With those last two that we did, they weren't. Okay, bacteria was hours, and then that girl, putting in double every day, or was it triple? It's triple every day, so time was in days. But most of the time when we deal, no, all the time when we deal with appreciation and depreciation, it's in years. And then lastly is your rate. And I gave you an example. I think it would be important to write that example. 5%, if I change that to a decimal, is 0.05. How many times did I move my decimal? 2 to the left. That's how you change a percent to a decimal. 2 to the left. You got to remember that because that's the number one thing that gets missed. You move your decimal 2 to the left. 2 to the left. Okay? Now, here are the formulas that you should have so far. You should have doubling and tripling. You should have appreciation and depreciation. And you need to remember that for those equations, T has to be in years. So jot all those down, and then we'll go back and do a couple more examples, and then you should be golden. We should finish this up on tomorrow with
So we don't have.
my favorites, compound interest.
We don't have a full set.
Yeah, we'll have homework today, but we'll finish the formula sheet up tomorrow. All right, so let's go ahead. Did everybody get those?
Oh, I didn't get the last.
You little rat.
Really, slow down.
No, I don't want to go to the last one yet. We're doing those tomorrow.
Okay, then I got it.
Okay. So let's go ahead and go back, and let's deal with these appreciation and depreciation. So look at this first one, number 3. A plot of land is valued at $30,000. The value of the land is expected to increase at a rate of 9.2% annually. All right, so let's talk about the important stuff. What's the first important thing you see?
30,000.
What's that?
Value.
That's my value. That's my P. That's my initial amount, right? That's what it's worth at the beginning. Then it says it's expected to what?
Increase.
What's that telling me?
It's gonna go up.
So if it's going up, it's what?
Positive.
It's positive. It's appreciation. It's appreciation, right? It's going up. And then the last thing that's important is 9.2%. Look, guys, 9.2. We move our decimal how? 2 to the left. So that's going to make it what? 0.092. You got to make sure you move your decimal correctly. I'm telling you, it seems like the dumbest thing I say, but it's the thing that gets missed the absolute most. People don't move their decimal correctly, and it causes the problem to get completely off. So here's my problem. It wants me to write the function. All right, so A equals P. You already told me that's my initial amount, so 30,000 times, is it 1 plus or 1 minus R?
1 plus.
Definitely plus. It's appreciating, it's increasing. And it's 0.092 raised to the T power. So if I clean this up, A will equal 30,000 times 1.092 raised to the t power. That is my simplified function for this particular equation. Now, we could apply it no matter what question it asks me next. But what question does it ask me next?
On the value of the land after 3 years.
After 3 years. So what are we going to do with 3?
Put it where t is.
We're going to plug it in for t. So go to your calculator and type in 30,000 times 1.092 raised to the third power. What do you get? 39,065. And since this is money, we should round to cents. So 12 cents. So $39,065.12.
If you don't put the money sign, is it wrong?
No, not really, but since I'm dealing with money, I usually try to put money. That way I just, I know what I'm talking about. All right, so how hard is that? It's easy, right? Look at the next question on the back. We're going to stop with this because we're not going to do monthly today. It says a new car had a value of $25,200 in 2011. The value of the car depreciated at a rate of 12% each year. Find the value of the car in 2016. Okay, first, what's the first important piece of information? 25,200. What's that?
Value.
That's the value. That's the P, right? Principal amount. Also, it tells me straight up that it what? It depreciates. How hard does it depreciate?
12%.
So 12%, guys, is what?
0.012.
Not 0.012. It's just, look, 1, 2 to the left. It's 0.12. And again, you see what I'm saying? That's the easiest thing for people to miss. You got to get through your mind. It's move it to the left 2. Okay? Move that decimal to the left 2. So the last thing that's hard about this, we'll get to in a second. The principal amount, we already said, is 25,200. It's depreciation, so we're subtracting 12%, which is 0.12. So last thing, T. Do I put 2016 in for T? No. What do I put?
Dude, 2016 subtracted by 2011.
Remember, the car was priced $25,200 at year 2011. How long is 2016 from 2011?
5 years.
So T is 5 years. See, they didn't ask us to write the equation here. They just wanted us to solve it. So you don't have to write the equation, just solve. So it's 25,200 times 1 minus 0.12 raised to the 5th power. So, unfortunately, after just 5 years, the price of that car has dwindled all the way down to $13,298.84. Okay? Questions about that? Anybody? All right, pretty easy, right?
Yeah.
Because I took away the monthly question for today, so I'm not 100% sure about that one, your assignment is on this worksheet I'm bringing to you now. It's just 1 through 5. 1 through 5 only. Because the last 3 problems, last 3 problems are all about monthly. And I didn't want that monthly in there. So, not today anyways. May do it Friday. I may finish that worksheet up on Friday for monthly. So your homework, 1, 2, 3, 4, 5. Follow the instructions, answer the questions that they're asking. Okay? Should be pretty simple, pretty straightforward. Any questions for me?
What number is it?
1, 2, 3, 4, 5. 1 through 5. All right, I'm going to go ahead. I almost forgot that I was recording this.
Do you have any .7?
Probably.